toucherait donc deux salaires. Je toucherais la retraite de l'éternel et le salaire de système. Et le salaire énorme de l'IETF, zéro. Mais quand même, avec, est-ce que ça. Je sais qu'au Canada, si on a plus tard, quand on prend la retraite avant,
Welcome to 6 month session. Oh, Bob. Sound test. Sound check. Oh, that's interesting. Oh, yeah. Don't be shy. Come close. Okay, this is 6 month session, and I assume everyone in the right room. Where else could you be? We have 2 hours, quite full agenda. So let's start. By the way, in this room, it is particularly important that you join MeetEchoQ if you would like to ask a question in the mic, because I cannot see people, especially in the back of the room. So it would be really hard to manage the queue if you do not use MeetEcho client. Thank you. And I'm handing over to Bob, who probably would like to run the chair slides.
Sure.
So click this button. So here's the note well, which I'm sure you have all could recite by memory at this time, since this is the second day of IETF. So it's the same note well as every other working group uses. And these are our usual MeetEcho meeting tips. I assume you're all well trained as well. This is information about the meeting, the Jabber room, the on-site tool, which you should be using. We're running the full tool up here so we can see the cues and whatnot. The minutes are being taken. And there's a link to the presentations. Why don't you talk about this one?
Indeed. So I hope nobody noticed that IETF network, the primary SSID, is now running in IPv6 mostly mode. So I guess if you're using Apple device or Chromebook or Android phone, those devices are now properly v6 only, and only users of Windows or Linux probably still getting a legacy address space. So if you do see any issues, please report them to NOC. But I hope it's not the case and everything should be just working as intended. So this is what we called deployment of IPv6, right, Bob? We're finally almost there.
Or this is an important step to the universal deployment of IPv6, in my humble opinion. So this is the agenda, the introduction we're doing now, and document status. We have a lot of document status. We have, I think, one hackathon report.
It'll mention another hackathon.
Okay. Ken will do that. We have node requirements and the reflection draft that's, I think, currently in working group last call. And then we have 4 other talks. We should have time for all of these. We put them in time allowed because they hadn't really been discussed on the list very much. But I think they should be good, all be good. So document status. We've had 2 RFCs published. The DHCP prefix delegation to clients and the deprecation of the IPv6 router alerts. So congratulations to the authors. We got these completely through the process. We have 4 documents in the RFC editor queue, which is, I think, more than we usually have. The first one, SNAC, radar flag is basically in waiting for publication. It's normatively references the actual SNAC document in the SNAC working group, and I think they're taking a lot longer than we expected when we worked on this, but hopefully they will finish this soon. I think their session is later in the week, and hopefully this will get to the ISG and be published in the next cycle, we hope. So then this document will be published at the same time. There's the zone, IPv6 zone identifiers and user interfaces is in the edit queue. The VPN service destination option is in the edit queue. And then there's clarification of the IPv6 address allocation assignment policy. This is just about done. All of the authors have actually approved it. It's an auth 48, but it's actually waiting for IANA to look at some registry changes, basically the title of this, and there's a discussion ongoing, and I think this is going to be resolved in the next week or so, and this will be published. But it's basically, once that's done, the document, the RFC editor will update it and publish. And we have 2 documents in the ISG queue. The first one has been in the queue for a while. It's the limits on sending and processing IPv6 extension headers. This has 5 discussed ballot positions. And from talking to Eric, and I think Eric may want to come up and say something. So, or come to the mic, please.
Yeah, there are a number of discusses, and I've been going through them and talking to some people, and some people think that their discusses are addressable, and some people think that maybe they can't really be addressed. And so I've sent an email to the author to try to sort of get their read on where they think they might be in terms of being able to address some of these comments. There's a question about whether or not if every comment is addressed, whether there's much of a document left at all by the time everybody has had their cut at the text. I'm inclined at this point to send it back to the working group, whereupon if we can't find someone to try to turn it into something that could get past all of the comments that were received the first time it came to the telechat, it might be best just to declare the document dead for now. You want to say that at the mic? This room is terrible.
I haven't looked at the discusses. I'm shocked to learn this, because I feel like we spent ages and ages on this topic, and you know, it's my understanding is that if we can't put the limit on it, then no one can effectively deploy it, because an extension header, because the people aren't going to do their hardware right. So I mean, it's really, like, I don't know what the issues are, but I just don't think killing it is an option, right, for the successful deployment, universal deployment of IPv6. I think it's like, well, I don't know, right? It seemed to me like we were arguing about, you know, number of angels on the head of a needle for half of the working group on this, and I thought that it was all settled. So, yeah. I don't think we can drop it. That's all I'm saying.
Well,
yeah.
read the discussed comments, but
yeah. I will.
Yes.
Yeah, it may be that we don't need to drop it. It's just going to take some new eyes to figure out how we go from where it is now to something that could get published. So, and also actually, I don't know if Suresh is in the room. Oh, that's right. Suresh can't make this, I think. It is possible that since the time that the last IPv6 extension headers measurement across the internet was done, which was some years ago, it is possible that some things have been getting better. There's been time between then and now for new router silicon to be deployed. So it could be that things are improving, and without measurement, we wouldn't know. So it might be that there isn't actually a need to put a limit on it if things are sort of getting themselves fixed. But we don't have the visibility to know that, or at least I don't at the moment. Maybe somebody does have some data out there.
John Linkova, last time I recall seeing results, it was Anna and Gore doing something, and I think their data was significantly more positive than what I observed long time ago. So at least you can always put a straight line through two data points, right? But I think, yeah, I would expect it to be better. By the way, I'd like to relay a message from the chat. Michael, are you suggesting you're willing to help with the document? No response.
I'll read the discusses, then I'll.
You can re-say what he said.
I'll read the discusses, and then I'll decide how much of a masochist I am.
It wasn't a hard no.
So Eric, thank you. Yeah, so I guess my personal opinion, I think it'll be good to bring it back to the working group, and we can see what we can do going forward. Okay, and then the other document in the queue is the basically ULA document, and this is just very close to being approved. There were some changes in.
Bob, just a thing, Tim Chon is in the queue for a while.
Sorry, where did he say?
Tim is in the queue. Sorry, Tim.
Oh.
Go on.
Hi there. Yeah, I just want to say quickly that this topic, if not the draft, is in RFC 8504, the nodes requirements, which we're discussing later this session. What's in there is very much more oriented to node protection against denial of service from certain extension headers and options being included. And what's come into this draft is very different from what's in 8504, but Tim and John and I need to make a decision for 8504 bis. We would like to remove the text that's currently in there and replace it with something a little more up to date. But unfortunately, this draft seems to have sort of overstepped in that it's conflated the protection of the node itself from the extension header options and bits with some good guidelines for what it should and should not process with the whole you shall not send an extension header longer than 64 bits or whatever it is. And I think if we separated those two apart, we might well have some success. And just finally, there was a paper that I posted about to the list several months ago that showed they did tests of the hardware itself, and in a lab, the extension header lengths, long lengths were accepted. So it's not a silicon issue; it's more a policy issue, it seemed. And I think Gori and Anna were testing that further as well. But yeah, separate out the node protection from the maximum length.
Yeah, that's exactly the sort of feedback I think would be required to understand what the document should be, really. Yeah, in the end, it might be that it's significantly smaller and more targeted than it grew to be.
Yeah, I agree. Thanks, Eric.
So basically, hearing all of that, and we already have an interesting discussion. It looks like, yeah, we need to have the discussion on the list.
Yes.
Okay.
But also on the 6724, yeah, that was approved. It's ready to go. But in the last revisions, some interesting text crept in, and Nick and others have been fixing it. So I think I just need to get back around to looking at the final diff, and then we can send it over to the RFC editor.
Nick?
Well, Eric mentioned it, but I did fix those. That was an oversight on my part. All that should be fixed, so should be good now.
I'm just going through with a fine-tooth comb. I found a bunch of like stuff that, like nits that need to be fixed. I figured since I had to sort of look at the sections, the requirement anyway, I'll send them to the list. None of these are important, but I'll send some sort of suggestions and we can take them or leave them. I don't think they're critical.
Okay.
And this is our usual reminder that other working groups may need 6 men's involvement. And we prefer to take on things, that are IPv6 related, but really focused on other areas. Once there's been feedback from that working group or the chairs that they're actually interested in this, as opposed to just an individual publishing a draft that doesn't have any support in the main working group. One thing that came up in the routing area working group is that there was a Yang model for IPv6 neighbor discovery. I wasn't there, but some of our ADs were there, fortunately. And the thought was that this document would be better suited to be in 6-man. So this has not happened yet. It's still been adopted in the routing working group, but I think we're expecting it to appear here, so you'll see more about it on the list. And we have a few words from our AD.
Yes, thank you. Just a reminder that this is the time in our annual cycle where the NOMCOM has released the list of roles that need to be filled. That includes my role as Int AD. So there are many other area directorships open. There's IAB memberships. If any of this is of interest to you, I encourage you to read the descriptions and apply. You can nominate yourself. If you don't want to nominate yourself, you can tell me and I can nominate you. That's fine. If you would like to understand what it means to be an area director, there's an Ask Me Anything, an AMA on Thursday. I can't make that one, so you can also chase me down in person and I can try to answer any questions you have, or you can chase down any other area director, past or present, and get their feedback as well. So please do have a look. Please do consider serving. It's work, but there are a great many rewards as well. So anyway, that's my PSA for the NOMCOM.
Thank you. All right.
Okay.
Next slide.
I guess there is no next slide. So I think next on agenda is hackathon reports. There are 2 things here. David will be presenting hackathon results in the moment, and I just like to mention that it was more than one V6 related hackathon. I think on Thursday or tomorrow, Happy Working Group, I believe, has on agenda other hackathon report from David Plonka about Happy Eyeballs measurement. So if you are interested, please attend the session. And okay, let me get the slides. Hold on. Yes, okay, it would take me a few seconds. Sorry, David. Yeah. Selection. Hold on.
Perfect. Right. I'm David. Jen and I finally, after planning for a long time, got together and did some testing on Rule 5.5 and 8028, which is useful for multi-router, multi-prefix setups. Quick recap of what we are talking about here. Rule 5.5. It's for selecting your own address when establishing an outgoing connection. You already have a default gateway next top selected at that point, and you need to pick a source address to go with that. Rule 5.5, if you apply it correctly, tells you to use something that router that you have selected has in fact advertised before. The way we tested this is there were two routers. The left one had higher priority, so that was what was selected as a next stop. And if the system behaves correctly, then a source from that router should always be selected. And to make sure that we actually see the broken behavior, we choose the addresses so that rule 8, if it manages to be hit, chooses the other address that the host has. So in the correct case, we can see the source address from the end host. That's what we look at. That's what we compare. RFC 8028 is the step after that, basically. When you have your source address and you're sending follow-on traffic, you should really use the router that originally advertised that prefix to you. For obvious reasons, otherwise you may run into filtering issues. This is mostly a problem when the network topology changes. The only fully correct implementation we found of this uses destination source routing. I believe that is the only way to do this correctly. I'm not going to claim it in case someone does come up with some other way. But if you don't know what source destination routing is, it's a draft in the routing area working group. You may want to look at that. It's going to go into last call pretty soon. And the way we tested this, kind of reverse scenario of the before, we actually changed the topology during this test. So initially, an address from the low priority router is chosen, and then we check if that router is still the router being used. In this case, the test needs to look at the MAC address because that's the only way to determine what router was actually used. The motivation for this, well, we want multi-homing with multiple prefixes and multiple routers on the same link to work. We've been discussing this for several years, I don't know how long. And for that, we do need Rule 5.5. We do want 8028. And this is also useful in a whole bunch of other cases, like renumbering efficiently, failing over if your connectivity changes without actually having multiple things at the same time. Jen has a draft on this suggesting the use of a different link local address on the same router for distinct connectivity. And we need actual data on how well this is supported. So physically, this was a Wi-Fi network that was connected through a very, very cursed bridge to the IETF network. I actually have the Wi-Fi AP with me, just for props. The network was connected to the IETF network in order to make sure that the devices actually believe they have internet connectivity. In this case, the bridge only allows IPv4, so the devices see they have IPv4 internet, and they go, oh, okay, I'm connected to the internet. IPv6 is filtered out, and the tester does whatever it needs to do for the specific test. It's a bunch of Python code. It's a web server. It tells the client over the web interface to go connect to various things over JavaScript with WebSockets. We also hold connections open and then change parts in the network and then check if the connection still works or if it moved. The code is up. It's probably not possible to run this because the setup is cursed is the best word I can pick here. This needs a bunch more cleanup work. The hackathon is 48 hours. We got it to work. That was the goal. Logically, you saw this already in the previous slides. The tester is emulating a whole bunch of routers. These routers don't actually exist. It just pretends that they do, sends the arrays as is necessary. We do have different preference for the default routers in all of the tests right now. The prefixes change, routers disappear, reappear. Yeah. All right. Things we were looking at, Rule 5.5. That one, if the end host selects the correct source address, we know that Rule 5.5 was successfully applied. I mentioned already, we chose the addresses so that Rule 8 chooses a different address so we can detect your failure case. For RFC 8028, the test setup actually claims a whole bunch of MAC addresses to use as routers. So by looking at the different MAC addresses, we can determine what next hop the end system chose. And thus, we determine if the correct router was chosen. In this case, for existing connections, that's the easiest way to test this. And we do change the topology in the tests, all the various ways, deprecate the PIO, deprecate the router itself, have the router just disappear by going into NUD and just not responding on neighbor solicitations. And we also barely managed to get to testing with RIOs. That was the last thing. We didn't get very far with that, but we did have one scenario where we also had an RIO from one of the routers, and we're looking at that still everything works correctly. Right, test devices, anything we could get our hands on. macOS, Windows 10, we had problems finding Windows test systems. Everyone with a Windows device had a forced VPN on it, so they couldn't disable it and connect to the Wi-Fi and go directly on the IPv6. We also didn't find the Windows 11 box. Android, Chrome OS, and Linux, those behave the same in all tests. For Linux, there's a special thing to consider, which is that if you have Network Manager takes over how RAs are processed, so that is a separate test item. And then we have the Rule 5.5 patch mentioned here. That is my work, which is not upstream in Linux, where I have been trying to implement Rule 5.5. So there's a description of the first test. Most of this I've already mentioned. It's just more detail. You can look at the various IP addresses we used here. You can see we deprecated the router, we deprecated the prefix. We stopped responding to neighbor solicitations. And in all cases, we have here with the two, the destination addresses are similar to the source addresses. That's Rule 8. You choose the address that is close to the destination address. And if that is hit, we know that we have failed. Yeah, the router preference is what determines behavior here, because again, the gateway is selected before the source, and we would have seen if that wasn't the case, to be clear. That's kind of a side outcome of this testing. For 8028, we started with only one router, which is the low priority router from before. This end host selects an address from advertised by that router, ideally, which already requires 5.5. But then we add back the other router, which wins as far as our RA priorities are concerned. So for new traffic, the end host actually switches over and uses source addresses from that. But for the existing connection that was established while there was only the second router, it should still use the second router because only that router is advertising the source prefix. And yeah, look at the MAC address, see what next up the client shows. That's the only way to see it. You don't have what router was used as somewhere in the packet. It's just the Ethernet destination. Results, actually looking better than I expected, at least. We did know that Apple implements Rule 5.5. We now know Windows also implements Rule 5.5. And they do handle topology changes correctly on Apple with an asterisk with a small bug. I have a separate slide about that. We did also know that Linux just doesn't implement it, and we confirmed that that is the outcome. We did also see that neither Apple nor Windows actually implements 8028, which is a bit unfortunate because we do need both if we want the use cases really to work. We did confirm the patch for Linux properly works. There's one edge case where it doesn't quite handle deprecation correctly. That just need to fix that. And for Network Manager, there's an extra slide. I'll get to that. Right, I already went through the results. Yeah. Network Manager, it actually installs a default route with multiple next stops doing equal cost multipath. That really doesn't work. It just breaks all the assumptions with selecting a source address. It kind of becomes impossible to distinguish between the routers. It also means that whether the device passes the test or not is random chance based on what hash result was influencing ECMP. So it's really indeterminate what happens. We have opened an issue with Network Manager that this is breaking things. We are in some disagreement whether this is allowed by the RFC. The actual final behavior is definitely not allowed because it talks about destinations, but definitely not ports, and ports are part of the ECMP hash. And even with destinations, it is very questionable whether this should be allowed. And if it is allowed by some ambiguity, then this might be worth clarifying. And the intent, I believe, is certainly to have a route with a single next stop. And we're hoping Network Manager can just fix this and behave that way. And I don't know of any other system that does the same thing. For macOS, we found what looks like a relatively trivial bug. If you deprecate the router, it does move over to the other router in the routing table with the route. But if you look on the flags here on the right on the slide, there's an I uppercase in the flags that the route has. And that apparently means the route is scoped to the interface, which seems to be somehow related to multiple connectivity and OS X managing switching between like wireless and wired and mobile. It fixes itself after another array from the same router that is now active is received. I believe Jen has submitted a bug report about this, and it looks like just a simple bug, and hopefully it will be fixed soon. Conclusion, yeah, rule 5.5, actually, yeah, it's around quite a bit. It's just, yeah, not evenly distributed. We do need to put work into Linux. Maybe not even for Linux desktops, but Android needs this. And yeah, we need to talk to the Network Manager people, figure out what we're going to do there. And in the long run, we already had CLAT on the test plan. We didn't get to it. Right now, the web page that you open on the device talks to the test manager over IPv4, because that was the easiest way to keep it separate from all of the testing. That obviously doesn't work if we want to test the CLAT. So that needs some change in the test setup. And there's also the problem that if you open the connection from the browser itself will do NAT64 without going through the CLAT. It'll just straight connect to the mapped v6 address. So we're not sure if we can automate this. Worst case, you need to manually type in some SSH or NC or SOCAT or whatever commands to trigger the connections that we need to test. If anyone has ideas for this, I'm all ears. It's on the to-do list, and we do expect failures with the way the CLATs work. They generally only pick one address from one prefix and don't particularly care where their packets get sent in terms of router choice. And yeah, we're going to look to confirm how that actually turns out in practice. And I think that's all of the slides. Any questions?
Lorenzo Colletti, what can we do with 5.5 and without 8028?
The steady state, at least, works properly. 8028 is most important when the topology changes and we need to stay on a router that is no longer preferred.
Right, so
with 5.5, like without 5.5.
So you can do multi-homing as long as both upstreams are alive.
Yeah, we will choose one by whichever router is preferred. And we need 5.5 to make sure we actually choose a proper source address for that one ISP that is in operation. Without 5.5, even that doesn't work, because again, like in the test, rule 8 will hit. And if the other address is closer to the destination we are selecting, then we pick the wrong source and nothing works. Mm-hmm. So it is valuable in itself, but I agree 8028 is needed to make this complete, in quotation marks.
Because I think depending on the implementation, what qualifies as a topology could cause the router stuck. That depends on the implementation. Like in Linux, any sort of like route added to the routing table would change that, invalidate the nest cache. So it's not clear, even in steady state, whether this will work, right? Our observed behavior of these implementations in these scenarios is that it does work, but we don't know what would. So I'm not saying we shouldn't. I mean, I guess I'm saying we shouldn't declare victory here necessarily, right? So I think in 6724 bis update we're requiring 5.5, which makes sense, right? But I think, I mean, I don't know, maybe we should put 8028 in node requirements. I don't know. I guess that's yeah.
Right. I agree.
Tim Winters, QA Cafe. So 2 questions or 2 comments. One of them, network manager with ECMP, there's no way they should be doing that. That'll cause all kinds of problems. So I would, whatever issue you're tracking with them, that's not a good suggestion for them. The second one I wanted to comment on, for the Linux patch, I assume that's headed upstream. What's the game plan?
I have been carrying that patch for a long time.
Yeah.
The problem is this is free time that I'm investing into this, and the missing work is cleanup and testing and writing an actual unit test to ship with the Linux kernel. And I also found a bug that causes a kernel panic during testing, actually after testing. It should be easy enough to track that down. The plan is to upstream it. Definitely.
Okay, that was my real question, what the plan was. Okay, thanks.
There is a consideration because this will slow down things for servers if they don't need this. But yeah. Do we have remote? Yeah.
Yeah, I'll put myself in the queue. Jan Linkova, 3 comments. First of all, yeah, I totally agree. ECMP stuff, even if text can be read that it's allowed, clearly we see why it's harmful. So we might want to clarify it, but I personally have not checked the text to see if it's just unclear or explicitly permitted or explicitly denied. Secondly, the funny actually thing that Android, at least in case of renumbering or topology changes, might survive just because, as far as I know, it disconnects when default gateway disappears. So at least new sessions would be okay for topology changes. It's actually, yeah, and my third comment, yeah, about Rule 5.5 without 8028. I guess it depends on the use case. If we are talking about like phones or laptops, I think Rule 5.5 already solves most of the problem, because we picking up new source address for new session, and it works unless there is topology change, right? But if we're talking about servers, for example, when it could be incoming connection to a specific address and you need to respond from that address, then it's a problem, yeah. So obviously, to get a full solution, we need both, but to low-hanging fruit is clearly 5.5. But the funny thing is, yeah, your patch basically does both. So we, yeah.
Just to clarify, Android does not disconnect when there's a topology change. It disconnects when all of the routers have gone away. So it won't. No. So that won't help you here. I mean, the good news is as soon as David merges his patch upstream, we will pick it up, right? I'm sort of more worried about the other implementation, because I don't think anyone really understands, from the people who are writing those implementations, I don't think anyone really understands how this actually works. And so we've tested it and we're like, oh yeah, it works apparently. But yeah, so anyway, we should maybe we should try a little bit harder to break those implementations, see if we can break them.
Hard already. Yeah. Go ahead.
No, I was just thinking, so Lorenzo, do you think we need to define the test cases and somehow make them, standardize them? What do we want to test? What implementations need to test for 5.5 and 8028? Because you yesterday raised some concerns that maybe our test did not cover all possible corner cases, right? So I'm all ears. What else do we need to test?
I mean, the IETF doesn't normally define test cases.
Doesn't have to be.
Yeah. The test code is public, even though it is not exactly usable right now. And I'm planning to at least polish it a little bit. And if we can just collect test cases, then that is probably quite valuable.
Yeah, my friends in the row back there from UNH Iowa have a bunch of test cases for the US government that test Rule 5.5. So I would strongly recommend starting with those test cases. They don't get run often because most implementations choose to skip the optional 5.5 rule.
Yeah.
But that would be my strong recommendation.
One last clarification, the ECMP thing, I'm just being favorable to the network manager people in I can see how they might have read the RFC text to allow creating an ECMP route. I absolutely agree this should not happen, and we need to communicate that, and yeah. Cool.
Thank you very much, David. And I guess T was next, right? Okay, I'm getting slides up. Yeah, hold on. Yeah, I'm getting slides control, no deployment. Here is your clicker, and I'll pass it to a few more seconds.
Oh.
Yes.
Okay. All right, I'm presenting on V6 node requirements. So for those who don't know, this is a document that resides in 6-man. That's about, we do this roughly every 10 years. We update node requirements for the newest information we have about IPv6 nodes, what they should do and how they work. So I'll start with this. This is our 3rd iteration of this document. And since the last IETF, we did a couple of things. One, people made it very clear they wanted to be able to do path MTU in all of the different ways they wanted to. So we added both now. So currently we say, hey, you have to do both. We've always had PMTU. Basically has always been in it. The change here is we added PLPMTU as a must. And the working group was pretty clear about that last time. So we added that. The second bullet, we just had a long discussion about the EH limits. So a little background here, Tim, the other Tim Chon, has kind of said what our issues are here. We had a draft, the last version of 8504 node requirements had some very particular text protecting nodes when processing extension headers. We wanted to remove that text because it feels a little odd in this document. We were hoping that EH limits was going to resolve that. So if you look at the draft, right now it points to EH limits. I don't think the authors or the working group is sold on that being the solution. But what I do think is we don't want this text to live here. It should probably live in a separate document. Looks like there's an ongoing discussion on the chat. If you're paying attention to the Jabber chat, sorry, I dated myself. It's not Jabber anymore, but on the chat room. You can go look there. You'll see the comments. I think that's the answer here is that we need as a working group to come up with some small text. I will say in our case for node requirements, we're really about node protection. Some of the other things that were in EH limits, I think are out of scope for what this document wants to do. We had a comment, someone said we should add, hey, there's a discovery of DNS encrypted resolvers. We added that as well. So those are the 3 things that have been in the document. To be completely honest, they're pretty minor. The big things we haven't taken on yet. We're hoping to take them on. I think I said this last time. We're hoping to take them on. I have a couple of slides for today that will hopefully help us as we add new stuff. So there's a couple of document updates we have to do. So 6724 default address selection. This one has got a lot of things in it that we need to make sure we update. I know the ULA updates are in there, and Rule 5.5, the magical Rule 5.5 we were just talking about. We have to update that. We have some very particular text about that. We're waiting for that document to go through, and we'll make the updates in our document. Another document that went up through updates was IPv6 became an internet standard. In this case, it was pretty minor stuff. We just really need to update our references. This document doesn't go wild and crazy with DHCP stuff. It's really just a reference update in this case. Another one, Bob sent some comments recently about adding hop-by-hop option processing. I think this is a fine place to talk about that. I think there's one other one other RFC we have to update around extension headers as well. So one of the things we're going to have to do, which makes sense, is talk about how extension headers have changed since the last publish of this document. So those are all what I would call document updates. Yeah, those are straightforward. I don't think I need questions. All right, here's where the questions start, and I will stop at each slide and give you a chance to, if people want to comment on them. So one thing, we have an issue for this in our tracker, which I think is at the end of this if you're curious. If not, we'll send it out on the mailing list for the tracker. The first one is adding DHCP PD per client. I think in this case, we're just telling people, hey, nodes might do this. We're not suggesting that nodes do this all the time. I think this is really just making nodes aware that this is an option and how it works. So we should add that. Another one that's come up, we haven't written text for yet. I'm not quite sure what, I think part of the problem we haven't added this one yet is figuring out which section it goes in, but we should add something about port control, PCP. Just that it exists and that nodes might want to implement it depending on what they're doing is really what we're saying there. The last one I think is a little bit more, I don't want to say controversial, but we're in this weird state. We can't get out of the state of 8028s not getting implemented. And so the suggestion has come up several times. I was a little leery. I was the last one with the pen. I almost stuck this in the last version, but my real question to the group here, and this is where I would like people to come comment. Are we okay saying must on 8028? Is this the time for us to put in node requirements? Everybody should do this. Should we be should? Should we just ignore the whole problem altogether? Comments?
Yeah, comments. I put myself in the queue, right? Yeah. So it's kind of funny. 8028 says should. So we kind of must, should. So I think normative language might need to be clarified. But I think we, like Rule 55 and 8028 is like crucial for preventing connectivity issues, right? So I see it as if you don't do this, things will break. So it's kind of actually justify must.
Yeah, so in the past, node requirements has said things like for Rule 55, we called out different behavior for type C host. So we've done this in the past. So node requirements has a little bit of a history of, hey, if you really want this to work, you need to do these things. And I think that would be okay if that's what the working group wants to do. It's a newer draft. We've learned some stuff, we could do that. So I was aware of the should problem. I think that's kind of the suggestion here is we want to tell people, yes, that to solve this, this is what you got to do.
So, oh, sorry, go ahead. All right. So
I think it's you.
I think it would be an amusing exercise to figure out if a type A or B host could do any of this correctly.
No, they can't. They cannot.
So maybe we should say that type A and B hosts are hereby banned because 5.5 is now going to be mandatory, right?
Yeah.
And it's going to be must. And so if you're a type C, I don't know.
I don't know if Brian Carpenter's paying attention, but he always has that great line, which is like, who must do this unless you're a small device, right? And I think the catch here, right, is we want to be careful of threading the needle between a thermostat in your house and your phone. Those are two very different things, and we want to be clear that, hey, you should be doing this if you're this type, and if you're a really small device that is not doing a ton of networking stuff, you're okay.
For what it's worth, on the 8028, I do think it should be must.
Okay.
Because if we're okay with 5.5 being must, there's sort of two come together, and I think it is a fundamental piece, right? If the thing is, if we want to do multi-homing, and we want to do host-based multi-homing, then the host must support multi-homing. No, it sounds tautological, but like we have to really think about it. If we want to do multi-homing and there's a bunch of hosts that don't do it, then we can't do multi-homing because it doesn't work.
Yeah, we're stuck. For sure.
In Ted's spirit of like we should say that you must do what we want you to do, I think in this case it is justified. So,
all
right. David Lamparter. My main concern with 8028 is that 8028 is not actually a good explanation of what you're supposed to do. Among other things, it just erratas kind of the introduction at the very beginning to exactly the reverse of what it has written. So my concern is rather that it's not a good pointer for this behavior. And I will plug the test source routing draft at this point, which I am an author on, disclaimer. It should be going into working group last call pretty much now, more or less. And it is a better description of the same thing, really. 8028 is a subset of test source routing.
Okay, well, I'll have to take a look at. I haven't looked at your draft in a bit. Maybe that's the answer. We'll write that one down.
Ted Lemon, I was in the queue, but it seems to have removed me.
Welcome, Ted.
Technical issues. So a couple of observations here. One is PD per client is actually fairly important in on the networks where it's in use.
Yeah.
And so we really, I think, need to have normative language about it. I'm not sure that it has to be a must because, see, I found a new way of saying it, because there are indeed constrained devices for which it might be too much.
Yeah.
But I think that it should definitely be a should, and the exception should be very clear and limited.
Okay.
And then, yeah, PCP should be a must. And 8028, yeah, must implement, seems right to me.
Okay, thanks. This is good stuff.
Okay, Jen Linkova, actually I would like +1 to what David said. Maybe what we can do, we can take very specific requirement from 8028 and put it there. And I am particularly have vested interest here because my Gula draft has a one-line update to 8028 because what it's proposed needs to be slightly modified about selecting using reachable default gateways. Because it currently does not say that, and I think I discussed it with Brian, and Brian was okay with the change. So maybe we can, instead of Gula go in and update on 8028, we can just sneak it. We can talk about that, sneaking it into host requirement.
Okay, we'll talk. Yeah. This one's come up a couple times. So this is one of the bigger ones that we haven't.
Tim, we have people in the queue. So Philip, do you like to comment now?
Yeah.
Yes, please.
Yeah.
Philip Teasel, multi-homing enthusiast. I'm really in favor of making it either a must or at least a should with a very clear exception in order to get IPv6 multi-homing anywhere in the next 10 years. On the other hand, whether 8028 is the right reference first, that's very questionable. I think we should get a good solution here, and I think David's suggestion was one of the best we can do at the moment.
Okay. We can take that back to the group. We'll definitely clean up some texts.
He just said
Nick, I think you're next.
Sorry, go ahead.
Nick, you're up.
I was just going to say, he said all the things that I was going to say.
Okay, thanks, Nick. Thanks, Phil.
So I, as a reader, not as an author, I would love to see a document explaining how IPv6 multi-homing would work. I know we have lots of them already, but I think a lot of them suppose, presence of legacy hosts and things like that. I think saying like this is the one true way, I don't think it's even that complicated. If you have source test and you have 5.5, I think it basically kind of works. And so having that written down in its own document would help. And I think if we add more scenarios to that document saying like, here's how this would work, here's how that would work, some of the test cases that we were talking about would just fall out of there, right? So I think that would help too. But again, as a reader, not as an author.
Yeah, I heard you. I saw what you did there.
Yeah, Jarlinkova. So basically, yeah, so what we discussed about test cases. Yeah, so basically, if you define the behavior, it's kind of test cases. So, and I remember we talked about that. So maybe yeah, it is a time to write something. But so yeah, let's talk about offline about writing that.
It would also basically serve as a demonstration to show people that like are skeptical about this, right? And even some in the IPv6 community are very skeptical this will ever work. I think saying, okay, here's exactly what is supported today, and here's how it works. I think that would be helpful, and like having a recipe of how to do it would really be helpful too, right? Because you could say if you're an enterprise, this is how you do it, right? Because right now it's very, maybe the text is all there, but it's like really fragmented. So and there is one thing that we still don't know how to do, which is to have the network elements choose your source address, and that just like is not done, right? So that's the only thing that is cannot be done compared to IPv4 multi-homing with this. So I think it's writing that statement down and saying, here's how IPv6 multi-homing works. I think that would be great.
Okay. All right, V6 only section. So this has come up a couple times. I think this is really just, I would call this a node requirements and informational document telling somebody who's reading node requirements how they might deal with a V6 only network. We don't have this section yet. We haven't needed it. Now we need it, which is nice. These are some of the suggestions we've gotten in the past for references. I don't have any text here. This was really just some of the things that have come up. Does anyone have any other things they'd want to put in a V6 only section? I'm assuming by Montreal this will exist and we'll have actual details to talk about, but I'm looking for high brush strokes here.
Pref 6.4 RA option.
Okay. Yep.
Right. Absolutely. DNS 6.4. What is that even? Like, do you mean synthesis or do you mean 7050?
7050.
Oh, no. But there's a document V6 ops.
So I'll say this, the issue tracker, someone who put in the issue put in 7050, but that doesn't mean that's what we need to do. I am just the messenger in this case.
But Pref 6.4 option though, yes.
Okay.
Because if you deploy a greenfield network, you don't want to wait that extra RTT before you get V4, right? So,
sure.
And maybe we can say, because I think in terms of like actual people, looking, I don't know if you saw Ule's slides, they're like, oh, IPv6 complicated. But I think partly it's, IPv4 is not quite that complicated. It's pretty complicated as well. It's just like, people know how to do it. So I think saying, okay, if you want to support IPv6 only networks, you must do all of these, right? That you can say, okay, like your thermostat doesn't need to do this, but if you want to do V6 only, then you must do these.
Yeah. Okay. I get it. Oh, this queue's filling up. I'm scared.
So I just like to second the Pref 64. I think that's really important for the downstream clients.
Noted. Thank you.
Florian Obsel, BSD developer. I guess for DNS 6.4, you want to say must not?
Boy, did I step in this one. Okay. Noted. Okay. We will avoid saying we'll try to say the right words and avoid that problem.
Jerninkova, as it's been mentioned, currently in IETF last call, there is a document which saying you should not. So the thing is, I don't really understand what DNS 6.4 on the host means. Local synthesis, yeah, maybe, right?
Yeah.
And I remember some people in the room were volunteering to write some document about that. So basically, how host does like all this local synthesis stuff, right? Because it's quite complicated, at least I'm not sure I fully understand that, right?
Yep.
But like DNS 6.4, it's like normal DNS, right? So I don't think we need to explicitly mention that, but local synthesis, yes.
Yes, I think that's probably what we will say. It's good feedback.
Andrei Tsalatkar, IPNCC, Jen, you basically stole my point here. I was about to say that, yeah, I really like the way like Apple devices are doing this thing where the application is sort of thinking it's doing V4, but the operating system is actually doing V6. The thing is, I always call it referred as something similar to bump in the stack RFC, which is something super, super old. And I think, first of all, this should be referred in this document, but probably there should be first something to refer to that will be something better than a variant of bump in the stack from 2012 or something.
Okay, thanks.
Jordi Palet, I think we should say something like, you must do self-synthesis, otherwise do DNS 64.
What do you mean by do DNS 64? Use network provided DNS or is
use the network provided DNS 64.
But the host doing it anyway, right?
Yeah, but what we cannot say is just do not use DNS 64. Because I think it's for sure self-synthesis is the best choice, right?
Yeah.
But if we don't have self-synthesis, we should.
I don't know if node requirements is the place to drop that gem, would be my author pushback here. I think there's a lot of things we can tell people about local synthesis and a V6 only network. You probably going to want to use it, right? And we can tell people that. I don't think we want to go wade into DNS 6.4 and whether it should be there or not.
Okay.
Mark?
Yeah, up the top here. I actually don't think we should be doing IPv6 synthesis at all for quad A, for A.
Okay.
You lose the routing table. If you want a node to work, in mixed environments or anything else, synthesizing quad A's is a bad idea. It really, really, really is. I just said the same thing for the DNS servers, where the suggestion was for IPv6 to synthesize it. I said no. Let the CLAT let the CLAT do the job. The application doesn't need to know how to do it.
All right, we'll take that
Preference IPv6 addresses, and if you end up going down to IPv4 address, that's so be it.
Okay.
Ted Lemon, just a data point on DNS64 and NAT64 and synthesis. The thread spec, which is for highly constrained devices, requires that all thread devices do their own synthesis.
Own synthesis.
So, and nobody has objected to that, and that code exists in every thread device that you can buy on the market right now. So definitely there isn't like a
That's a
node
good data
constraint
point.
issue here.
Thank you,
It's not
Ted.
that hard.
It's very helpful. Okay, so look for actual details about this. Thanks for all the feedback. This is really helpful to the authors. So we'll have something in Montreal for V6 only section. This is, I think, is a little bit less. There's some issues that have been put in there, different DNS questions. If you have thoughts on these, feel free to read the issue tracker and comment on them. One of them that stuck out to me was the second bullet here, which was prefer V6 servers to V4 servers. I haven't thought nearly enough about this, but if you have an opinion about this, please reach out to the authors. This one just got tagged from a previous. And captive portals was the other one that's in there about redirecting the DNS server. Mark, you have thoughts? Oh, he's making his way up to the mic, I see.
Just as a record, Bind already does prefer IPv6 to IPv4 servers for DNS. It biases it by 60 milliseconds or something like that.
Okay, that's good to know.
It measures the round trip time, but gives IPv6 addresses 60 milliseconds advantage.
Okay, thank you. That's good info.
Ted Lemon, another data point. The thread stuff, if there's a quad A record, we don't even synthesize.
You don't?
Yeah.
Okay. It's good to know. Okay, thank you. That's good.
Eric?
A data point on the resolver one that discovered recently is there's a challenge that at least some OSs like Linux only allow you to have 3 resolvers in the actual working set. So it's a challenge for operators who want to actually provide more than one V4 and more than one V6 resolver.
Okay.
So I think there might be some operational things around how do people work around that limitation.
Okay, I'll have to look into that.
Or maybe even requiring that you support at least 2 of each.
Okay, thanks, Eric. Okay. Okay, last one. This one came up about 2 weeks ago. So the deal here is node requirements has, since its inception, always had this magical line that I have quoted, that hosts must send router solicitations and must be able to receive router advertisements. Seems basic, yes? So there's an issue here, and this has always existed, and I think I knew this, but I had forgotten. No neighbor discovery, so 4861, does not require host send RSs. It has a magical should send RSs line. And so there was a little bit of discussion about this. I am very leery of removing this from node requirements because this has always been something we've required of nodes. I understand that it is a slight difference from neighbor discovery. Lorenzo.
We need to update 4861.
Okay, so I said text about this. 4861 has a lot of updates. I am happy to write another very small draft. I think Jeremy agreed to co-author on that says, yeah, we should take that one section. It should be a 2-page draft that says, here's all the reasons you should send these: energy efficiency. If you're not sending RAs and waiting for a blasted RA, you could be in pain. And the world's changed. I don't think Jeremy was suggesting opening all of neighbor discovery. I think that's
oh god no.
a mad.
we tried that a few times and never
Yeah,
did well.
I would not do that. I am on board with a draft that says, hey, we should change that should to a must.
We should absolutely not remove it. Absolutely not remove it.
Okay, thanks.
Because otherwise you're waiting, and
yes,
we know a lot more about the battery life implications of arrays than we did.
Yeah, 100% agree. Okay. All right, so I'll take that. We won't remove it from node requirements. There's a separate item here about a new draft to fix the RS transmission issue, separate from that. All right, I made it. Did I make it in my time slot? Did I do it? All right, I did it. Great, we're here. I do want to quick plugs. There is an issue. It's on GitHub. Please feel free. Others have, like I said, added comments. We'll try to go through them, and we'll see you all in Montreal. Thanks, everybody.
Great. Thank you, Tim. So, Lorenzo, you have.
Can I ask a question about the chair slides? Sorry.
Yes.
So, 6724 update. I sent a bunch of nits. The only one thing that, because of it's on author 48, the only one thing that we might want to discuss is the text says that, I forget what exactly, but the host should change its mind when, the host should not consider something local anymore when it's deprecated. I think that should say when it's removed. But that's so that's something that we might want to, because when something, just because something got deprecated doesn't mean it's no longer local. It is still local, it's just deprecated. But yeah, that's just something I wanted to quickly mention.
Okay, yeah, so may you send this to the list? And I see Timon's in the queue anyway, so.
It's buried into a big sort of list of things that I sent.
Okay,
At the top, it does say there's only one that's substantive, but if people say TLDR, then.
Yeah, I think on that one, if Lorenzo just speaks to Nick, who's in the room, we'll fix that very quickly. Yeah, just a quick question. I didn't notice Tim 2 mentioned SNAC and how far into that we want to go with 8504 BIS. The section in there currently about sort of IoT type stuff is very minimal. Do we want to go there at all? And if so, how far do we go?
Yes, Tim, is it actually a question to the authors or to the group? Or
it's to the room, sorry, yeah, or to you, to anyone. As if it was on a slide by Tim. What to do with SNAC? Ignore it, just say it exists, say some more detail about it.
Since you asked it of the room, I mean, the whole point about SNAC is that an unmodified host should sort of work, and that it was designed for that. So hopefully we don't need new host requirements to make SNAC work. Otherwise, we should just like roll back the existence of the working group. So is that correct, Ted? Is Ted gone? My assertion is that if we need new node requirements to make SNAC work, we should retroactively cancel the existence of SNAC. Right? The whole point is that it should work on unmodified hosts.
Okay, yeah, that's good. I've never seen Ted run that fast before.
The statement that Lorenzo just made is correct if the hosts actually implement the requirements that are in this document, or even if they don't to some extent, because it's working now.
Okay, so that's exactly what we can say in 8504 BIS then, just a very short thing that says that. Yep. Great.
Okay, thank you. We're just perfectly on time. So the next presentation is Ron, who is like ready. Okay, reflection utility. Ron, here is your clicker. You'll get control in a second. Just a second. I need to click. Yeah.
Okay, Ron Bonica, HPE. Hopefully this is the last time you'll be hearing about the IPv6 reflection utility. So what is it? It's a diagnostic tool, something like ping, something like probe. You send an ICMP message to a destination, it sends you an ICMP. Oh, I'm sorry. Oh, much of a difference. Okay. What is this reflection utility? It's a diagnostic tool, something like ping. You send an ICMP message to a destination, you get an ICMP response. What's it all about? The response reflects back at the probing node the probe exactly as it was when it arrived at the probed node. So the probing node sends a probe. The probed node reflects the probe back exactly as it was when it arrived. Now, the next question is, what? It changed? What about the end-to-end principle? Well, packets do change in flight. We all know that routers change packets. They decrement the hop limit. They change the DSCP. NATs change source addresses, destination addresses, port numbers. Routers change things like the segments left field in a routing header or mutable destination options, also mutable flags sometimes in a routing header. Yes, packets do change in flight. What's more, middle boxes change ICMP messages as they're being reflected back at the sender. And they do this for a very good reason, particularly in the case of an ICMP error message. They change the original packet that's embedded in the ICMP error message so that the receiver of that error message can send it up to an application, and the application can match the original packet with the ICMP message that it elicited. So we had a previous last call on this that was interrupted. Someone pointed out that we could get the exact same behavior by sending any old UDP message to an unused port. Looking at the ICMP message, the ICMP destination unreachable, the original packet would be embedded in that, and we'd have exactly what we needed. For a while, even I was convinced this was a great idea, until somebody pointed out that middle boxes change the contents of an ICMP error message. They change the embedded packet in the ICMP error message. So the alternative solution is interesting if you don't care how the packet changed while it was in flight. But if you do care how the packet changed, the alternative solution isn't going to help you. The alternative solution was good, though, because it requires new code, no new code. It just hides some things from you. So yes, it was almost the alternative solution was nearly adopted, but someone pointed out this RFC 3022 that talks about ICMP messages getting changed on the way back. Okay, one more topic around this, and this is RFC 8335 considerations. In a previous version of this, an RFC 8335 BIS that's working in the internet area updated RFC 4884. So did the current draft. This was confusing. So we decided rather than, in this draft, rather than referencing RFC 4884, we would reference the RFC 8335 BIS and let it update 4884. That cleared out the problem. So what's the next steps? We'd like to complete the working group last call. I believe it's in process right now. It's in process right now. Please read it. Please comment on it. Also, if you read it and support it, we'd like to hear some more voices because we haven't heard all that many so far. Questions?
Hi, Ron. Zafar Ali, Cisco Systems. Many thanks for addressing the comments and the text, the new text. You already said that the existing method coverage. The question that I have now is, yes, so there is an existing method. Yes, this is 3022 RFC that says that The net box, the middle box can go inside the packet and look at the ICMP error payload and then can do the translation on the addresses. Yes. But the RFC also said this is done for privacy reasons. This is done so that the internals of that particular network are not exposed to outside. So now you have a new vehicle to export those internals of the network. How does this satisfy that privacy concern, which was all the 3022 was written for?
This is actually for more than privacy concerns. Let's say TCP originates, sorry. Let's say for a minute that TCP originates a segment, a SYN segment, to open a connection. That packet reaches a middle box, and the middle box changes the IP addresses and the port. That's what NATs do. It hits the ultimate destination, and something goes wrong. Let's say it's a destination unreachable. The destination sends back an ICMP message, and embedded in that ICMP message is exactly the packet as it was when it arrived at the destination, with the translated address and the translated port number. If the middle box, if the NAT box allowed that ICMP message through and it arrived all the way at the sender, the sending TCP would receive that ICMP message, look at the embedded IP message, and try to match that embedded IP message with one of the SYNs that it sent. It would look at it and say, I can't do that. I never sent a packet to this address or this port. The middle box that translated the address in one direction needs to translate it back in the other direction. It's not so much a security problem. It's what you need to do so you can match the outgoing packet with the embedded packet in the ICMP destination unreachable.
I'm struggling with something. So if the packet is, I'm the sender, like I'm the middle box in the middle, and then something come behind me, on the send side towards you, I have a protocol that is just doing some UDP message to you. This is not an ICMP error at the moment. So it goes to you as a UDP payload. I did not do operations. When it comes back to me in the ICMP header or the embedded packet, I go in and modify that. And
Yes.
that is what RFC is saying, is that modification is only done so that the internals, addresses, and the translations are done with the privacy. So I don't know how this fixes it. I can discuss more offline, but that's the only struggle I have. But other than that, many thanks for addressing.
What we're doing is putting, okay, we'll get together offline.
Thank you.
Nicola, I just realized that your draft probably needs to say that intermediate boxes must not modify the content.
Yes.
Because
and
I just search for must not in your draft and I do not see
it does not appear. Good comment. I'd be glad to add that. Please do not modify the reflection objects.
Yes, and my other, I sent this on the list, but I think my main comment on the draft is it seems for what it's doing very complicated as opposed to just saying, send me the packet back. It's got all these, you have a registry and you have all these, only send this back or send these two things back. I don't really understand why you need all of that.
We do have a reflect all, which means send me the whole thing
I
back.
understand. And why isn't that just the whole thing? And why have all the complexity?
Actually, we would be glad to take away the other ones if the working group wants that. I'm thinking that in some cases, it may be a violation of the reflecting node security policy to show everything. Maybe there are some things I don't want to show you about how the packet has changed en route to me. So it's a way to.
Yeah, but then the sender has no control over it anyway.
That's true. Actually, if it helps, we can remove everything except reflect all.
Carl?
So just responding to Jen's comment regarding the normative language must not modify the reflection object. So at some point, this was actually the language in the document. And then there was one of the comments we received in working with Pascal, or after working with Pascal, was that we probably shouldn't use normative language with regards to middle boxes. And we removed that normative language. So it was already there, but based on the comments we received, we decided not to use uppercase must not.
Interesting. Yeah, problem is that it's actually strange because vendors need to know how to process that new message, right? So your document defines a new message. It would be really nice to describe for both sender, receiver, and intermediate nodes what to do with it. Otherwise, they will get confused and start modifying it, and it will basically defeat the whole purpose. So to make it, for this to be useful, we must say they must not modify that, I believe.
Yeah, so I don't disagree. I think if generally there's an agreement that we can use normative language here, I think I personally agree with that. Yeah.
Zafar again. So yeah, I agree with the comment that Bob mentioned. This is really receiver driven. Receiver decides what it wants to expose and what it doesn't want to expose. If the receiver doesn't want to expose something, it will just filter it out. So for sender to say, give me this, give me that, it just add complexity.
Okay, so it sounds like we have consensus to leave only the reflect all and get rid of all the other objects.
So if there are any comments or disagreement with that, I would like to see them on the list.
Okay, thank you very much.
Okay, and the next is something interesting, something which is not a draft, but something which came up from the discussion we had this weekend during Hackathon. And I believe it's definitely in charter for this group. So Andre is going to talk about neighbor discovery.
Okay, so I don't really know whether it's a protocol or configuration issue. It's something about off-link prefixes that, yeah, I like to use, and I learned the hard way that there might be some issues. To quickly to put you on the same page, basically, in router advertisement, you can set L flag, which means on link to 0, and if you do that, the host here will configure an IP address, but will not configure any connected route. So there will be the IP address, just the one IP address, and everything, including one address higher or lower, will be sent to the default gateway. That's the definition how it's supposed to work. It's quite useful, especially for like public networks where you don't want to allow layer 2 communications between different hosts. So you can block it, and with this off-link prefix, you can still allow hosts to communicate with each other via the gateway. And if you try that, the first issue you find is that, yeah, it works. Yeah, so the host on the left, you can see that it has /128 address, will send, instead of to the host B, it will send it to the default gateway. I'm here using next hop with IPv6 addresses, but of course, in the packets, these are MAC addresses. I'm just using IP address as a symbolic name for the next hop. So it goes to the default gateway. The default gateway will send it back, but because the default gateway is sending it back via the same interface it arrived, it will also emit redirect message saying, hey, the host B is actually your neighbor, which technically is true, but this is not something that you want because you have the isolation enabled on the network and you don't want hosts to talk to each other because it's not allowed in the network. So this is yeah. So you somehow have to convince the router that it shouldn't send redirects in this case, but the neighbor discovery RFC doesn't say that. And second issue is even more interesting because it only manifests with Apple devices apparently, because they are doing the right things. So let's say this is a home CPE, the router, and because it's a home CPE, it also do recursive DNS, and therefore it announces in the router advertisement that the prefix that is on the network is offlink, and also that the recursive DNS server is actually the address of the router. And the important thing is, even though the prefix is offlink for all the hosts, for the router, of course, the prefix is onlink because the router has to be able to send the packets coming from the internet to every host that is on the link. And this leads to the fact that when the host wants to contact the recursive resolver, which is the very first thing the host will do, it will just send it to default gateway, which is the correct thing. But when the router wants to respond, the router needs to start neighbor solicitation. So it starts soliciting from the address that was asked, which is the global address inside this prefix. But since this is offlink prefix, this neighbor solicitations come to the host, and the host is thinking, why is this guy talking to me NDP? This is not my neighbor. I'm not going to talk NDP to anyone who is not my neighbor. So it just ignores it, and it just doesn't work. So what is in 4861 regarding this? On the left, this is the redirect messages. It just say the router should send redirect message, and there is no if, there is no condition like if this is offlink prefix, maybe should not. And regarding the neighbor discovery, it actually say that that the host should always use the address that is originating of the traffic as a source of the neighbor discovery message in order to like pre-fill the cache and prepare for the other end. So yeah, I think this might fix these issues. So basically, there should be a means to prevent emitting redirect messages other than setting up firewall rules, which is what I do now. And probably there should be also slightly less optimal solution that the router should use link local addresses for all outgoing neighbor solicitation messages, which would prevent this issue with talking with offlink host from the wrong address. But I'm not really sure about this. Maybe it's just maybe it's not problem of the protocol itself. Maybe it's you should talk to vendors that are producing routers, or maybe you should just not use the address that is in offlink segment anywhere to prevent the issue number 2. So that was my questions and my solicitation for an opinions or discussion whether this is worth pushing somewhere forward.
Jelinko, put myself in the queue. Actually, could you go back to redirect slide? I'm very much confused. Section 8.1 of 4861 explicitly said that host must drop redirects coming from non-link local addresses. Redirects are supposed to come from link local addresses always. So I don't see why this is an issue at all.
This is the redirect is coming from link local address of the router. That is correct.
From link local.
From the router. This is just normal redirect message because this is just a message emitted by the router if the router sends the packet to the same interface from which it was received. So it is proper redirect by the protocol.
Okay. So your problem is that redirect exists. Okay. But strictly speaking, it's a policy decision, right? So router would, because remember that router would route that packet, right? Yes. In addition to sending redirects. So if you allow a host to talk to each other, you probably shouldn't be redirecting. Yeah.
Exactly. It's a policy decision, but the thing is, there is no room for a policy. There is nothing saying in the neighbor discovery RFC that it should be controllable by policy whether the router emits redirects or not. It just say router should emit redirect. Full stop.
Right. Yeah. David Lamparter, can you go back one slide?
We mean forward, probably.
No, back. Slide number 2.
I didn't mean back.
Okay.
You have there on the interface the address of the host with the 128 prefix length. That is not what I get when I set this up. I do get a 64 address, but no route on Linux. And then it actually works. I don't know if this is a Linux invention. I don't think this is described anywhere. Maybe offlink is underspecified in this regard.
Well, that's basically the point here, I guess. So I'm not really sure. I did it out of my head. I didn't check it. So maybe, but my understanding is that the only meaning of the number in after slash in the address config is actually the connected route. So if there is no connected route,
apparently. I mean, judging by the behavior I'm seeing, that mask length is also used to check whether you should send the neighbor advertisement reply, or rather, whether you should accept the source for the neighbor solicitation. Yeah.
Yeah, it's correct that actually a Linux host and both Windows hosts are very okay with talking to the offlink router, but not Apple devices.
Can you go forward a couple of slides, like what RFC 4861 says?
This one.
Yeah. So I think your first issue is an operational issue. The standard already says that the router should only do this if there is a better first hop node. And if you configure the router to tell it to announce an array with L equals 1, well, L equals 0, then that's clearly not better. So I think there could be an operational draft that's saying, please allow us to configure this, or please do it right? Because as Jen said, it is a policy decision, right? So it's basically like how you configure it, right? And the router, like, you have to tell the router that network isolation is involved, right? And so in that case, normally it is better, but if you drop the packet when they try to talk device to device, then it's not better. So you just need a way to teach it that it's better. This text doesn't need to change though. 4861 is fine because the router just needs to be a bit smarter and figure out what better means. The other thing about like the Apple device, I think it's wrong. I think 4861 says that you ought to do this. And the reason is like when 4861 was written, we had all of these like weird like multi-link networks and like this off-link and on-link assumption, which are very different from IPv4. But the way if you read the RFC, I think what it says is you basically need to send the NA, even if the thing is like not on link in any way to you. I think that's basically the RFC. If you look at the code that says, here's how I process an NS, it doesn't check that there's a route pointing to it. It basically says you have to add the neighbor cache entry and then you need to reply. So because it was written for MBMA or links, right? So I think the Apple device is wrong. It should reply. But yeah.
Okay, thank you.
Yeah, Tim Winters, QA Cafe. So you definitely want to solve this by policy-wise or config-wise, configuring the router to disable sending redirects, which most routers support -0 config ones, which most of the time home gateways will not send redirects. They panic and forward the traffic. So I agree. I'm with Lorenzo in that I don't think 4861 has a mistake. I think you just need to write a new draft that says when you're isolating, you should configure that. Most routers, enterprise routers, to my knowledge, have this knob. So I don't think this is a controversial thing. I think this is just, there are lots of things that people have access to in routers that aren't specified in 4861, right? So Linux has a redirect enable flag in syscontrol.
Well, not really for v6. That's my point why I'm just stopping it with firewall rule, which is not very efficient.
Yeah, so I mean, I think the answer to this is, yeah, you should write a small draft that says when doing isolated, you should probably give some people some advice because I don't think this is very intuitive. So I would cache, I think you should say, hey, if you're doing device isolation, routers need to support disabling redirects.
So do you think, if I understand you correctly, do you think that I should start writing a draft about, probably for v6 ops, about how do you run insulated network properly?
Yeah, I think that's what you want to say and tell people how to configure this would be my advice.
Okay, thank you.
Cool, yeah, thank you. We just ran out of time, so thank you, Andre. Problem statement. Okay. here you are.
Hi, I'm Yolo from ZT, and this presentation is about problem statement with aggregate header limit for IPv6. And we presented last IETF. So here's first is a recap. So aggregate header limit for IPv6 indicates the total header size that a router is able to process at full forwarding rate for IPv6 packets. So why the IPv6 AHL, the nodes or the path, need to be aware? So first question may ask is, can I enable the use of IOM, network slicing, and etc. together along a certain SRv6 path? Would it result in big packets of bigger header, a bigger extension header size than the downstream nodes able to process? And the second is, can the controller calculate a parse that can process packets under certain IPv6 extension header size? And some IPv6 aggregate header limit collection methods are also analysis in this document, mainly based on the existing work of PassMTU and the MSD. So we have analysis of PMTUD style using ICMPv6 arrow and the hope by hope style. So you can define an hope by hope option for the collection purpose and the IGP signaling style. But they have their both have their limits. So here are the updates since last IETF. So mainly thanks for Eric's comments, and you found that the discussion around the 6 MHz limits is related with draft. So the first update is on the definition. So I highlight the update with the blue color. So IPv6 AHL is the total header size that is from the IPv6 header chain up to any headers that are part of network encapsulation. For example, the innermost transport layer, Ethernet frame, or other IP header. So in the last version, we only mentioned the transport layer, but not all the packets have the transport layer. So, and the second update is on, we add some security considerations because based on the AHL, the system design may be indirectly speculated, such as the size of the buffer, the hardware configuration, and the system version. So if you want to do the AHL collection, you may consider that you use it only within a trusted domain. So welcome feedback, comments for, so is the concept of IPv6 AHL needed? So is it the definition of it accurate? So is a collection required? So, and the plan is to work on the collection mechanism if there's a consensus on the problem states. So that's all. Thank you.
Yes, thank you. I saw you send the draft to the list, but I have not seen any discussion. So I'm wondering if anyone has read the draft. Okay, so please read the draft and provide the feedback, and we'll continue the discussion on the list. Thank you.
Thank you. My name is Zafar Ali. I'm from Cisco Systems. I'm presenting this draft on behalf of my co-authors. This draft is about ICMP error handling in a services-based VPN network. So very quick recap of problem statement is scope is SRv6 VPNs. And further scope is, or the problem statement lies, or need for this draft lies, when the customer have deployed what we call uniform model, which means that customer, the provider, is okay to disclose internal addresses and details of internal of the network to the outside. So transparency case. The draft uses C to C traceroute as an example, but the applicability is across any ICMP error message. Now, notice CEs can be an IPv4 node or IPv6 node, and the goal for this work is not to have any changes on the CE nodes. So quickly, recap of uniform model. So what happens in the uniform model is when the packet comes to a PE node and the PE node is applying an encapsulation, so upper IPv6 header, then in uniform mode, it copies the TTL or the hop limit from the customer payload to the outer header, the provider header. So to see how this or what is proposed, we're going to take an example when a CE sends a traceroute probe to the network, and its destination for traceroute is CE2, the CE on the other side. And the TTL is set to 2. So the packet arrives on PE1. PE1, because TTL has not expired on PE1, PE1 applies the SRv6 encap, which is to take the packet to PE2 using the VPN SID at PE2, and that encapsulation happened on top of the packet that comes from CE1, the traceroute packet. Now the packet travels to P1, and the TTL expires at P1. So now P1 has to communicate the ICMP error to CE1, back to CE1, the TTL expiry happened. And for that, what P1 does is what we do similar in MPLS, is that let the packet go forward because PE2 has forwarding set up already to send packet to CE1. So it's basically let this packet go forward. So that's 3. So it constructs the ICMP error, either ICMP v4 or v6, and put the destination for that in the upper header, being the VPN SID of PE2, which is the same SID on which the packet arrived. The packet goes through the transport network or the provider core, hit PE2. PE2 does not need any change because PE2, the packet is received by the VPN SID. So PE2 can then decapsulate that packet, look at the inner IP, which has the destination address of CE1, encapsulate the packet back to go to CE1, which will take the packet back to CE1. So that's the processing at the egress node. Egress node does not need any change because everything is set up in its forwarding plane because we let the packet go forward on its original path. On the ingress PE, also there is no change for any change required for ingress PE because the packet arrives on ingress PE with the destination with the VPN SID of the ingress PE as the destination address, which is the outer header, and the inner packet contains the ICMP payload, which is intended for CE1. And at this time, because the PE1 is local VPN SID for PE1, it looks into the VPN table how to forward that ICMP error message to CE1. It finds because it has the VPN route for that CE1, and it sends the packet, which is the inner IPv6, inner ICMP error to CE1. So this is like we have some implementations from Cisco and Juniper, and we like to have this working group draft adopted, and any feedback is appreciated.
We have people in the queue. Sasha?
I'm Sasha Weinstein. If I remember, what this draft describes is exactly what some existing implementations all have been doing for years for MPLS, in MPLS networks. And to the best of my recollection, this behavior has never been standardized by the MPLS work group or by the Layer 3 VPN work group when it existed. No, never has been considered by the proposed by the in the best work group. Simply nothing. So my question actually is, so I have two questions. One is whether you plan to present this to the best work group as well. And the second one is why do you, I have looked up the draft and it, the intended status is standard track. Since there is no standard in the MPLS case, personally, I think that informational would be a better match for this draft. But that's my personal opinion.
Thank you, Sasha. Yeah, I agree that this is exactly how MPLS is done in MPLS. So this is acknowledged in the draft. And regarding intention status, we do not have any strong opinion on a standard track versus informational. This is fine. We can have that discussion. Regarding on other working group, we are open to the chair and the working group if they like to this work to be socialized somewhere else. We did present it to Int area, and we think that this is because this is the 6-man is more suitable for 6-man because 6-man did the SRv6 O&M work, but there is no preference. This is really up to chairs and AD to guide us how they would like us to proceed.
Again, this speaks about IPVPN or SRv6, which is handled by BES. From my point of view, BES, at the very least, it should be presented to BES, and then the workgroup chairs could decide where this draft could be progressed. That's all.
Yes, thank you.
Sajid.
Let's speed up a bit. We have 1 minute 40 seconds.
Okay, Greg Mirsky, Ericsson. Following the Sasha comment, in your opinion, how this mechanism is different from the draft that was discussed in NVO3 group and its transcending trace route?
I do not know. So if you give me the pointer for that draft, I can give you an educated answer.
Yes, it's an individual draft that was then expired some 9 years ago. NVO3 working group transcending trace route.
Thank you, Greg. It's quite possible because this in VPN or encapsulated scenario, these would be the technique people use. Thank you.
Okay, thank you. David, I think you are next, last but not least.
Just one question. Do you guys have any preference for the working group as a chair, or you discuss offline?
Let's talk about it offline just for
Okay, thank you.
Yeah. Slides, clicker. I'm getting slides.
Right. Hello again. This is perfect for closing because if we agree on it, it creates work for other people, not ourselves. Let's see. Who here is aware of the general problem with IPv6 multicast and Wi-Fi? I don't know. We discussed this before. This is how it's supposed to work. Wi-Fi does beacons. After each beacon, you send multicast traffic if you have some. Clients are supposed to wake up for all of these beacons by default. If they don't, they lose multicast traffic. Exactly that is happening because waking up for receiving is quite costly, and if you have to do it every 100 milliseconds, which is the default beacon interval, you do a lot of that. And I think the worst we've seen is every 8 beacon that you wake up for. And apparently every second is quite common now. I don't have the exact numbers on this. I think Lorenzo has brought up this quite a bit on the mailing list. So you just lose multicast traffic, which for IPv4, for IPv6, it's quite a bit of a problem. Now, the thing is, there is a part in 802.11 called flexible multicast service that creates a protocol between the station and the access point that allows requesting exactly this from the access point. The client can ask the access point, hey, can you please give me this group, this group, this group at an interval of every second beacon or every third beacon. In the example here, the client has requested every 4th beacon and the AP has agreed to that. So it's a way to do exactly the same thing as the clients are doing now for PowerSafe, except the AP knows it's going on and the AP buffers multicast traffic at the appropriate interval. Yeah, it works with a counter. So I've been asked some things about this function. Here's FAQ. So importantly, the AP has final say on this, and it needs to agree on an interval for each group that is common for all users of that group. So you can't have the same group at different intervals for different clients. And there's a limit to the number of distinct intervals you can do. Lots of detail about this. If you want to know more, please read 802.11 2020. There's a pointer down there to the actual part of the spec. Now, the real problem is that spec is unfortunately optional. It's not required by any certification, so no one implemented this. I am hoping to get some kind of consensus here that maybe people can look at it and we can get an agreement that this maybe should be used for IPv6 so we don't lose all the RAs. And if we can get that consensus, I would like to take it to the liaisons or find some way to communicate with the Wi-Fi Alliance, ask them to just make it mandatory, basically. And that's it. I'm not expecting a great amount of responses here because I guess most people haven't looked at what this protocol actually does. And that is, I need a few people to at least read up on it and double check that I even understood it correctly, because I'm not going to claim perfect understanding of 802.11. I think that's not possible. But either way, yeah, we have questions.
I feel like I'm the next contestant, Ted Lemon. So I think, so I'm not actually any more clear on the protocol than you are, but this sounds like a good idea. And there are people who are more clear on it. So we should probably get it through to them. Another option, in addition to Wi-Fi Alliance, would be to try to push this through Matter, which I can maybe work on, because the problem with Wi-Fi Alliance is its very lowest common denominator. Matter is a little bit more high end, and that may mean that, like, at least we can sort of create some market pressure that might then motivate the Wi-Fi Alliance to move, even if they don't move off initially. So there's stuff we can do.
I need to read up on what exactly Matter does here and how the certifications work, I guess.
Jordi Polet, I have read the document, and even if I am not a deep expert on the topic, I agree. I think we should push for that.
Thank you.
Lorenzo, this looks awfully complicated. And in the absence of any known implementation, do we think it might even be implementable? Right? Because if it's not, then
it needs to exist on the network side first, really. I don't think it makes sense to start on the client side for this.
No. My point is, if we don't even know if it's implementable, then
we know it's not implemented. I can tell you, none of the enterprise access point solutions do the AP side of it,
right.
So it can't be in use for lack of network side support.
Right, so we don't have existence proof of an implementation, which means it might be impossible to do correctly. For example, it might be impossible to do the right thing in the presence of like different clients with different requests, or
So
whatever.
I did read up on what is supposed to happen when different clients request different intervals. The answer is the AP decides the interval. the request has a maximum field on it, and the AP can just change the interval to something lower. It's lower because this causes delay, and the idea was the client wants to place a maximum on the delay.
So that if someone asks for one, then everybody pays more power? Yeah.
Presumably.
So I think maybe we would want to try and figure out who wrote this and see if they thought that it could be used for this.
Yeah.
Because if, you know, if you tell manufacturers, oh, we all need to implement this, and then one badly behaved device says, oh, I want one, and everyone like loses the power optimizations that they wrote a bunch of code for, and that's not a good outcome. So yeah, it would be nice to know, you know, I don't know if we can figure out who wrote it and ask them, hey, do you think this will work?
It's in 11v, and it does explicitly say in the text that it's intended for power save. So at least the goal was kind of this, I guess.
So Ted Lemon again, is this something we could like just implement in OpenWRT?
I think you need firmware support from the Wi-Fi chip. Maybe you can do it on MediaTek chips because they have relatively low firmware to host barrier.
Okay. Interesting.
So I think that's it. Thanks.
I think the way we usually determine consensus is by like adopting documents and so forth. So I think that would be the, you know,
right,
a little more discussion on the list and then request that we adopt it in, then we can do an adoption call, and then we can see if there's legs behind it.
To be clear, this is not intended to ever be an RFC as far as the draft is concerned. I just needed something written down. But yeah, that sounds like a plan.
Yeah, but I guess we need to get consensus of the group. Like, is it a good idea? Is it something we want to do? And who is doing this is completely different story, right? Yeah. Okay.
So thank you. We are done about 4 minutes early. So I think we will see you, hopefully see you all in Montreal. Thank you.
Pressed, it's on. It's saying this. Pressed? Pressed. Because it's mute button.
What it really means is people like to know the mic is.
Yeah, I guess in MediaTek.
It's done.
Yeah.
Oh, that must be good.
Not a Wi-Fi person. No, neither me, but it makes sense because I have seen